Uh, lesson 5. Any questions, class? Any questions so far? And you can also write down the questions and email them to me as well. So let's look at lesson 5 now. And let's just see here. Lesson 5 is configuring network addressing and internet connections. So because this is a networking chapter, and to be able to computers to see each other, they have to have an address. If you remember, I used the example of the U.S. Post Office, right? You write a letter, you put the address of the person on the envelope, and you put the return address on the envelope as well. So if it doesn't get to the person, the letter comes back to you. Well, I said the same with the computers. Every computer on the network has to have an address. So you got to configure the address on every computer. Okay, so let's see how that looks. We'll look at the objectives. Is compare internet connection types, use basic TCP/IP concepts, compare protocols and ports, and compare network configuration concepts. So compare internet connection types. So let's see here. Okay, here let's take a look at the diagram. Let me expand it out a little bit. First of all, let's see the bullets. You see here internet connection types and modems. You see the internet exchange points. You see internet service providers. You see point of presence known as POP. You see point-to-point WAN links, digital modem types, and router versus modems. You know, all these things up here for the internet, if you work for the internet service provider, you will be working with that. Us, like even me, I don't work with this other than with the router because I don't work for the internet service provider. But it's a device that helps with the connection to the internet. But here, if we look, let's start off with the central point here, okay? This is the internet modem, as they call it, an internet modem. But in reality, it's a device known as a router. Now, you see right here, 1, 2, 3, 4 ports. This is for the wired computers. So these computers here at the small business connect. Each one will connect to one of these ports so they can send messages to each other. Okay, it's the wired part. Okay, this one, notice it also has these antennas because it's throwing out wireless signals. This is also an access point built in there as well, an access point that we just finished talking about it in the chapter we finished. Okay, so it's throwing out the wireless signal. So these devices that are wireless are also connected to the network right here. So these computers can talk to each other, and they can talk to each other whether it's wireless or not. They all can communicate because you're running both wired and wireless. Well, this device has a connection right here for the internet, for the wide area network. So anybody that needs to get to the internet then will check and says, well, what I'm looking for is not in here. So I'm going to go out to the internet port and go out to the internet and find www.microsoft.com or one of those. Okay, so that's what you're seeing here. You're seeing a network environment, and you see what comprises the network. And remember, we talked about two terms. We talked about the WAN and the LAN. Remember, the LAN is what? Local area network. That's within the building, close proximity, right? And then we talked about the what? The WAN, wide area network, beyond the building, further out. So this, you could say, is the LAN right here. Over here is the WAN, because if they want to connect to get to a web page, they have to get out of the LAN by using this device and exiting through here to get to the WAN. So now, because we've used both terms, hopefully this can start putting the pieces together for you, a LAN and a WAN. And because to get out to these web pages, you have to have a service provided to you, provided by the ISP, Internet Service Provider. we pay this institution, our $40 a month or whatever it is that it costs to have that service. Okay. So here we get to see basically the same diagram, but now notice one thing. We see some numbers there. See here, we see the base number is 192 period 168 period 0 period /24. That means something in Netwrk. So because I said every computer has to have an address, this computer has the address of 192 period 168 period 0 period 101. This one has the same first three numbers, but the last number is 102, 103, 106, 104, 105, and this router also has an address. It's 192.168.0.1. So now you can see that these are the addresses. So if this computer was sending some information to the laptop, the sending address would be 192.168.0.101, and the receiver address in the message that it's sending would be 192.168.0.104. Okay, class, so now you can begin to see that the computers are given an address. When you log into your computer, there's an option to configure the device, and it opens up a little screen that you type in the address on that computer. So some technician has to go to all the computers and type in the addresses. So again, here what we need to glean out of this is what? That to be able to communicate in a network, each computer has to have an address. If somebody would forget to put an address on this computer here, that computer would not be able to connect. It would not be able to make a connection. So again, another part of networking, having all the devices to have an address. Okay, digital subscriber line modems. Right here, class, we're seeing a device here that lets us get out to the internet, okay? If we don't have that device, we're not going to be able to get out to the internet. We have to have that device. Where does this device come from? Well, the ISP that you're subscribing to is going to provide you the device so you can be able to get out of it. So that again would be the digital subscriber line modem. We know it as short for DSL. The technology, how it delivers the packets of information back and forth, is broadband internet access over last mile copper telephone line. So just understand, they put that box in your house, and then they run something to your house to be able to have that link to be able to go in and out, right? The traffic of what you're sending in and out. We call it it's asymmetric DSL, but the real name is ADSL for asymmetric. Asymmetric means that when I'm downloading, it's downloading very fast. Let's say I'm downloading, let me just use a number. When I'm downloading, it downloads at 100. But when I'm uploading, sending something over to the internet, it's only 50. So uploading is going to be slower than when you're bringing things down to your computer. That's why they call it asymmetrical. The two speeds of upload and download are not the same speed. The download always faster, upload that you're sending is slower. ADSL, but that's the way the industry works for home networking. The symmetrical means that if you download it at 100, you can also upload at 100. The same speeds, up or down, upload or download. That's the difference between the two services. Normally for home use, it's ADSL. And then the box is known as a DSL modem. And somebody comes to your house, when you subscribe to the service, they put that box and you're good to go. All you have to do is connect your computer. And if you have wireless, you're connected. Okay, so remember the connection is RJ45 for the wired. The DSL uses a phone connection as well. The phone connection looks like that as well, but it's smaller than the RJ45. That's known as RJ11. And then, of course, DSL has something called splitters. Splitters just means that you could have a telephone call and be looking at the internet at the same time. They will not interfere with each other because these come with what they call a splitter. You can have data and voice at the same time. Okay, another service is known as cable. You either have DSL or you have cable. You choose, and sometimes it's not by choice. Sometimes it's what's available in your neighborhood where you live. I used to have DSL for a few years, and then later on they came out with really high fast speed cabling, fiber optic cabling and all that in my area. So then I went with a cable modem. So now I don't have my DSL modem. Now I have a cable modem and a cable. But that nonetheless, it's still the same service for you to get internet and get to the web pages. And either you're going to have a slower upload speeds and faster download speeds. So the services provided are the same. The only difference is that their box is called something different. Here you have the cable access TV. You have the hybrid fiber coax. If they're using fiber or they're using coaxial cable, they call their service DOCSIS, stands for Data Over Cable Service, interface specs or specifications, and their box called a cable modem, not a DSL modem. Again, RJ45 cable like the DSL modem, but they don't use a telephone like the DSL because the DSL uses the cable for networking, but they also use a telephone connection. This one doesn't use it. It uses the cable for networking, but it uses a cable connection, which is coax cable. And coax cable is what's used. So that's the two that are used right now. Some people right now have DSL, others have a cable. Either one works just as good. They're very close competitors. Okay, give me a minute here. Let me just. Okay. Oh, now they talk a little bit more of if you were a technician that works, let's say, for Xfinity or for Windstream, fiber to the curb and fiber to the premise. All they're saying there, class, is just how every neighborhood has a central connection point, and from there they start throwing out the lines to each house in the neighborhood. Okay, so fiber to the curb, fiber to the premises. The premises would be your house. Fiber to the curb again. Service provider runs fiber to the street cabinet. That's a central location in the neighborhood. Very high bit rate, very fast. That's what they're saying. Fiber to the premises again. That's where passive optical. They run the networking cable to your home. Again, if you work for one of those companies who would be involved with this, we are just learning about this to know how things happen, but it's not something that you really right now would really have to know and be an expert at it. So just informational purposes at this point in time for you. The passive optical network here is known as PON serves multiple subscribers. So again, it could serve the whole block in your neighborhood. If fiber is run to optical network terminal, known as ONT, installed at customer premises. So this one is where they put in this box in your home, and the cable comes into your home. ONT converts the optical to electrical. So anyway, that's how computers work. They convert from digital to analog. It just converts another signal. It's invisible to us, transparent. All we know is we're connected to the internet, and we're getting to our web pages. The fixed wireless internet access. This one says geosynchronous orbital satellite internet access. Again, along the lines of what I said earlier. The satellite is in space. Okay, so the satellite, again, 25,000 miles in space. There's multiple satellites out there. That's the one that's sending out the signal. So if you had internet access to this service, when they talk about latency, the reason that they mention latency is because stop and think about it. The signal has to go up 25,000 miles to the satellite and then come back down, right? So there's a little bit of a delay. Now it's happening in microseconds, milliseconds. It's very, very fast, but it's still latency compared that if you were connected directly here on Earth to your subscriber, your cable or DSL modem. So that when you hear latency, that's what they mean. But again, it's very minimal that we may not notice it. And then you have the low Earth orbital satellite, again, antenna alignment. If you have your satellite dish or whatever, you point it, they tell you point it to the west or point it to the southeast, and so you can get that line of sight that they call. And then you have the WISP, wireless internet service provider, point-to-point microwave. So if you are getting wireless service, you can also get it through a microwave, to the long distance connection as well. So multiple services out there, class. Multiple services out there. You say, well, why would I want to get a satellite connection? Well, one of the things that we're fortunate because we live in the Houston metropolitan area. So we got all these services and we can select. That's great. But I used to, when I finished high school, I said, I want to go and see the world. And I went to California, and I went to this middle of nowhere, dumpy town called Barstow. And all that was there was tumbleweeds and sand and windstorms. And when the wind would blow, you could barely see outside. And the sand would creep in through your windows. And it was horrible. They're surrounded by a few mountains. And there was only one TV station. And if you didn't like what was on TV, that was it. So it was horrible. I'm telling you, I got out of there as fast as I could. But now, if you have satellite service, it doesn't matter if you live in a place like that. Because you subscribe to the satellite service and you get all the other channels and everything else. So now it's great. But at that time, they didn't have this. So that's where you would want to use something like that. Okay? We don't relate too much to that because we live in Houston. In Houston, we have everything. But some places they don't. Okay? If you are in West Texas, again, in the flatlands, and where it gets super hot in the summer and super cold in the winter, and the windstorms and the tumbleweeds, the satellite will service you. We think of the networks as the data network, right? But, don't forget about this little device here, right? Or the tablets. Okay, that's a cellular network. You also pay a service for that to use your smartphones, right, class? The 3G is one of the earlier generations that came out, known as a global system for mobile communications. And it uses something called a SIM card. It's a little card that goes inside your phone that identifies your service provider, it identifies you, the user, and it uses something called CDMA, code division multiple access. That's the way the signals go in and out. Then a newer version came out, and that was the 4G. Okay, the long-term evolution converged standard using a SIM card. So this provided faster service, better, more reliable service, right? And other things that catch our attention and we want to get it. And then the 5G. The 5G is connection through an array of massive MIMO antennas. So when you see MIMO, is multiple input, multiple output. It means that you have multiple pathways. So that's going to be faster all the time. So that's why the 5G came out. So everything's a lot faster in roaming and fixed access. So again, you're familiar with some of this because you actually own a device that uses this. That's known as a cellular network. Okay, so we are talking about these devices, right, class, that that allows us to go in and out of our network, right? If you're connecting over the LAN, local area network, and you want to go out to the internet, now you're going to go out to the WAN. So there's a device that takes you out to the wide area network, and it's got to be on your network. It's got to be a part of your network. It's called the router, what you're seeing there on the screen. Okay, here, let's see what they say. Logical network addressing and forwarding in an inner network. An inner network is when you have your local area network and you have your wide area network. You have your inner networking, right? You have the LAN router, this device here, established logical subnetwork. So inside, if you think of you being in the classroom, we all can connect. Okay, and that's the LAN, as we already know. And then you have the WAN router, connects LANs to the internet. It tells you here, right here, connects LANs to the internet. If you didn't have the router, and let's say we were in the classroom, we can still connect to each other in the classroom because we're on the LAN, on the local area network. But if you wanted to go to the internet, you would not be able to go to the internet because you didn't have a router. This is what allows us to get out of the LAN and go to the WAN, to the internet. So that's what the router will do for you. So that's the function of the router. Connects LANs to the internet, connects LANs across public service provider networks. So again, to another network. So it allows you to get out of your LAN to go to another network. The internet is a network, by the way. The router. Don't forget this one, the router, but it does. Firewalls. Well, we know that we have a network, right? And information is going out from your computer out to the internet somewhere, to another network. Okay, maybe to an email to your friend that lives in California or in Florida. Okay, your email message left your computer from your computer from your office or from your home, and got out to the internet to go to California. Right, so information is going in and out, in and out. Okay, so you want to protect your network because there's a lot of bad things that can happen because they call them the hackers. The hackers are the people that want to do bad things to your computer, to your data, steal your information, your credit card number, and do all those bad things. So you can put another device on your network. It's called a firewall. The firewall stops the bad traffic from the hackers coming into your computer, to your network. It will block. It's a protection for you. Okay, so let's see what they say here. Enforce rules for allowed and blocked traffic. Network access control list, ACL. You put in those rules. You say the IP address that's allowed to come into my network starts with the number 192. You say if the number starts with 172, don't let it in, block it. So that's a rule you can set up, a criteria you can set up in the firewall. Okay, so you can set up the traffic that's going in, traffic that's going out, so the source destination, and other things called protocols. So later on, we're going to learn about protocols, other things like that. For example, you can say allow email traffic to come in. Do not allow other traffic known as telnet to come in. Okay, you decide what you're going to allow. If you're working for a company, they're going to tell you what traffic to allow, and you know what to put in those areas to block or not block the traffic. And then implementation, dedicated appliance. Yeah, it's a device that sits right at the entrance of your network, and any traffic coming in will be let in or it will be blocked, depending on the rules that you set up. So it's built-in function of the router. Some routers come with a firewall already built in. Not all of them. Big companies have a router standalone and they have a firewall. They have two devices. Smaller businesses have the router and the firewall all in one device. And then network firewalls versus personal host firewalls. So the network firewall is that device that I just mentioned that is put at the entry point of the network. Okay. Now there's something called a host And well, one more thing about this firewall that's put at the entry point is one device that blocks or not blocks the traffic for the whole network. Now, you have another type of firewall called the host firewall. The host firewall is on every single computer in the company. So if there was 100 employees in your company and you were using the host firewall, that firewall will be installed on every computer of every user in the company. Host firewall. Okay, class, the difference, the other one is just a device, only one, put at the entry point of your network, and it protects all the 100 users. The host is one installation per computer. So if you have 100 computers, you install it 100 times. Everyone would have one if you have host for firewall, and it just protects your computer only. By the way, if you're using Windows, you have the host firewall. You can set it on or off. It's your choice. Windows automatically, Windows 10, Windows 11, even Windows 7 gives you the host firewall. You don't pay for it. It comes with Windows already. Later on, we're going to see where it's located. So if you want to set it on, it's not a bad idea to keep it on or for you to play with it. In your Cert Master Labs, you're going to be doing labs with the firewall, so you can get to learn how to use it. So the firewall to protect bad traffic coming into your network. Okay, so what did we look at here? We looked at the internet connection types and modems. One is the DSL, the digital subscriber line modems. One is a cable modem. Another one is a fiber to the curb and fiber to the premise. And this, now we're talking about the service provider that's running the lines in your neighborhood, okay? The fixed wireless internet access, right? That's where the satellite out in space could be sending out a signal, down to Earth. There's some companies that have a big old satellite dish down on Earth that gets a signal from the satellite, and then from that dish down on Earth, they start sending the connection to the individual homes. Again, that's known as the fixed wireless. And then you have the cellular network, which is for our smart devices. That's another network, but it's still a network because it still carries your voice. If you send a picture to your friend, it's a network. It's sending the picture to him, a text message as well. And then you have the router, which is the device on the network that allows you to exit your LAN to go to the internet. And then you have the firewall to protect you from hackers. These are the bad guys that want to come into your network and start destroying things to protect you. That's for protection. All right, class, we're going to move on to topic B, use basic TCP/IP concept. Let's take a short little break, no more than 10 minutes. And we'll come back and pick up with topic 5B. So I'm going to go ahead and just mute myself for I'll wait till I see each one of you again. So just so we can take a little break. So let's do that, and we'll come back in about 5 to 10 minutes. I'll wait for all of you to be back. Okay, just let me know if you're back. This way I know everybody's back before I start again. So just let me know, let's say here or on the chat, just put on there, I'm back or something.
Excuse me, Professor.
Yes, sir.
So I haven't done the homework yet. Still working on the answers.
Okay, so try to use this week to do that.
Okay.
You'll have some time because the next class, remember, is going to be the recording. So you're gonna have a lot of time. So yeah, I'll go ahead and wait till you get them all.
Got it. Sure.
How are we doing with the Third Master Labs? Have you gotten them, Adam, already?
Yes, I got him.
Okay, Nicholas, you have them, I think. And Nicholas is back. How about Shelly? Because what I want to do, once I finish what I'm going to lecture on, I'm going to get into the Third Master Lab, and I'm going to run the first one so you can get familiar with it. Uh, eh, as soon as I finish the lecture part, and then that'll be part of our lab besides your activity labs that you're working on. But let me wait. Shelly, I think is back. I'm hoping I'm right. Shelly, can you hear me? I see some activity with Shelly. So I guess then that I will go ahead. Class, if you don't mind, what I'll do is I'll just mute you. If you have to speak to me, it just unmute. No problem at all. It's just because sometimes if your mics are on, it causes reverberation and it distorts my voice. So that's the reason that I do that. For no other reason. Shelly's back. Great. Okay, we're gonna go ahead and get started. So let me mute everyone and let's get started. And like I said, and then I'll do that Third Master Lab. Okay, so hopefully you can still see my screen. I see a chat here. I'm not sure why you can't hear me. Oh, okay, Shelly, your mic is probably muted, and that's fine, and no problem as long as you can hear me. If you do want to speak, just look at the icon of your microphone, and it shows a red line over it, means that it's mute. If you click on it, it unmutes it. Okay, that's good. You guys are getting familiar with the platform here. Okay, so we'll continue then, and now we're going to look at basic TCP IP concepts. TCP class is known as a protocol. It's like a set of rules, and it what makes networks connect to each other. Here, if we look at the TCP IP, they call it a model, a 4-layer model. The 4 layers are the application layer at the top, then it's followed by transport, then internet, and then link layer from top to bottom. What happens at this layer is the applications. The TCP/IP is a suite of utilities that do something, but just to make it a little bit clearer for you, because you guys are not networking just yet. Your email program, you're writing an email to your friend. Well, you're working at the application layer. All these other little utilities that do something specific, and we're going to learn about each one of those as we go through this course. The transport, this is what carries the email that you send to your friend over the network to get to his email box. The internet, this is when it's going across the line, the wire, to get to the other end, okay, to where you're sending. And the link, really, that's just the physical connection. The network part, the actual cable, the cable you can touch with your hands and connect to your computer and to the wall. That's known as the link layer. And that is what takes the information of your email and puts it on the wire, drops it on the wire, and then it goes on the wire. And it travels all the way to California, to Florida, wherever your friend is, and your friend receives the email. So the 4 layers. IP addressing, IP4 addressing. Okay, we already know that computers are going to have an address. They explain here why the 32-bit number, actually, it's a 32-bit number address. And why is it a 32-bit number address? Because computers don't use numbers like the way we use. I remember earlier in this course where I talked about, the base 10 numbering system, or the Dewey Decimal Numbering System, and we said the numbers are from what? From 0 to 9, and you can make up any number. Well, in the binary, it's only the 0 and 1, only 2 numbers. And that's what computers understand. And that's how they store the information inside of the computer in binary form. So each one of these digits that you see here is called a bit, B-I-T, a bit. And it takes 8 of those, 8 bits to make a character. For example, to make the letter A, the number 1, the question mark, anything. It takes 8 of those. So here, if I look at this, I see 1, 2, well, right here, 1, 2, 3, 4, 5, 6, 7, 8. Let me hold off on that. Okay, the reason for a 32-bit number is because it takes 8. Every byte is a bit. It takes 8 bits. 1, 2, 3, 4, 5, 6, 7, 8. So right here, there's 8. This is a byte. B-Y-T-E. 1, 2, 3, 4, 5, 6, 7, 8. So that's a byte. A byte is made up of 8 bits. So we have 8 here for 1. 8 over here, 8 over here, and 8 over here. So 8 times 4 is 32. So 32-bit binary digits. So you divide it into 4 octets. So every address on the network is made up of 4 parts. These parts are called octets. See here, octets? Octets meaning 8. So 8 here, 8 here, 8 here, and 8 here. So 4 octets. But each octet is what? 8 bits, right? And we already said 8 times 4 is 32 bits. So it's a 32-bit number. And the way the octets, the way to express, you can see here, express each octet as a decimal value. And they call that a dotted decimal. So the value of this octet is 192. The value of this one is 168. The value of this one is 0. And the value of this one is 1. Okay, so what they're doing here is they're just converting the binary to a decimal. So we humans can understand more in decimal than we do in binary. So for now, just remember that. So let's just keep going on so they can elaborate more on what you're seeing here. Because I know right now you're going like, wow, what is this, right? So let's keep going here. Okay, here, let's see, IP version 4 address encodes 2 values, the network number, network ID, and the host number, host ID. So every number that we see it represents 2 things, and we'll see it here in a minute. Portions are distinguished by a network prefix. Bits and prefix set to 1 represent network ID. For example, 24 bits. Right here, we have 8, 8, and 8. That's 24, and then 8 more is 32, but only 24 have a 1. Okay, these 24 or these 3 octets are representing the network that you belong to. And I'll tell you that in a minute, what they mean by that. And then this one, the last 8 zeros, are representing the number of the computer, of the workstation. So if we look at this, for example, if I look at 192, well, I don't like this example. I'll look at it at a different one in a minute here. So anyway, really earlier you saw something that had /24. Let me see if they show us that. Okay, they're not showing that here. Showing that here. They're showing it here. Okay, so right there, the /24 here means that it's 24 ones right there, 24 ones, /24. So that /24 means this is the network ID, and this is for the host. So every number has two parts. So think of the classroom. If we're in the classroom, your computers at your desk, they all have an address. But the address on each of the computers in that room have the same number here for the first three, the same number. The only number that's going to be different on the computers in that room is going to be here, this one. And I wanted to see if they could show that. Oh, okay. So let me elaborate a little bit more on that. Okay. Let me run Paint just to show you real quick. It's a simple example, but I think I need to do it because I want to be as clear as possible with you guys. I want to make sure you understand it. For example, here, class. You see, this thing's being difficult. Second year class with this. This thing's locked up on me. I just wanted to be a little bit clear on that. Just give it one more try. Just give me a minute here. All right, we're fine. We're fine. Okay, class. Look at what I have here on the screen. Okay, I have this in yellow here, okay? I put this little matrix here, class. I call it my conversion matrix. This that I put up here, class, is only for you to use to help you to understand a binary, okay? That's the only reason. Because when we're talking about, we look at the octets, right? An octet, for example. Let me put one up here. If I do 192.168.1.5, for example, like that. I have my 4 octets, right? 192.168.1.5. Okay. There's 8 here, binary digits, 8 here, 8 here, and 8 here, that you know is 32 bits. So each one is an octet, right? So when we're dealing with binary and octets, you only need to go 8 places, but you only have 8 places. So notice what I did here. I started with 1, and I went from right to left, and I went how many places? I went 1, 2, 3, 4, 5, 6, 7, 8. Okay. I can go 256. I can keep going. And after 256, 1024, and then 2058 or something like that. But there's no need to go more than 8 because we're only working with octets, only octets. So this conversion matrix is one for you to remember, so because it's going to help you with knowing, understanding binary. And why, you may ask, did I choose these numbers? Well, because if we're talking binary, which is base 2 numbering system, you're gonna do we're gonna go with base 2, taking it with the exponents on base 2. So we're starting off on the right side. So 2 to the 0 power is what number? 2 to the 0 power. If you're talking about exponents, 2 to the 0 power, which would be 2 to the 0 power, equals a 1. 2 to the 1 power equals a 2. 2 to the 2 power equals a 4. 2 to the 3rd power equals, let's do it. 2 times 2 is 4. And 4 times 2 is 8. See there? So you start off with the base 2 and start out with the exponent of 0. And then you're only going to go up to the 7 places, which is 8, really, because 0 up to 7 is 8. Because it's 0, 1, 2, 3, 4, 5, 6, 7, 8. So that's the reason for that. Now you may be saying, you know what? I hate math. I don't want to deal with exponents. Okay, you know an easy way to remember that? Start with a 1 on the right. Double that. What's double 1? It's 2. Double the 2. What's double 2? 4. Double the 4. 8. Double the 8. 16. Double the 16. 32. Double 32. 64. Double 64. 128. Okay. So again, this yellow bar here only for your use only, and it will help you convert and understand binary. So, for example, here I have the decimal number 15 here, the decimal number 15 right here, and put it in green so you can see. And if somebody told you the 15 what is it in binary? If you're going from decimal to binary. So here, let me go. It's every number is eight. It's eight binary digits. Okay, so by using this conversion matrix, all you have to do, class, if you're dealing with the number 15 in decimal, just from here, find the numbers that will give you 15. Look at it. What numbers will give you number 15? Well, 8, right? And 4 is what? 8, 9, 10, 11, 12. And 2 more, 13, 14, and 1 more is 15. So whenever you have a binary number, and it's going to go below this matrix that I have set up here to make it easy for you, as I said, right here, you put the binary number underneath, and then you put a 1 underneath the numbers that will make up the number that you're looking for. You're looking for number 15. So I put 1, 1, 1 here, gives me 15. So if they were to ask you, what is the binary number? What is the binary number of 15? Well, you already know. 1, 2, 3, 4, 1, 1, 1, 1. That number equals 15. Because if I put that number down here, wherever I have a 1 underneath the yellow here, I will add those numbers. Let's look at another one. Let's look at let's do 25, okay? No, yeah, let's do 25. Okay, 35. Let's do 35. And we're looking for the number 35. Okay, if I add 32, okay, so that means I don't want to add 128 because it's too big. It's more than 35. I don't want to add 64 because it's more than 35. 32 is less than 35, so that one I want to put a 1 because I want to add 32. I don't want to add 16 because if I add 32 and 16, that's going to be more than 35, so I don't want to add 16. Do I want to add 8? No, because if I add 8 and 32, that's going to be 40, so I don't want to add 8. Do I want to add 4? Let's see, 4 and 32 is 36. No, I don't want to add 4. Do I want to add 2? Well, if I add 2 to 32, that's 34. Okay, well, it's still less than 35. Do I want to add the 1? 32 and 2 more is 34 and 1 more is 35. So that number here now is 35. So the number 001 00011, that equals equals 35. That's how you convert. Okay? You start off, copy this if you don't remember it, but it's so easy. Start with a 1, double it, all the way to 128. And then after that, if you're looking for whatever number you're looking for, okay, whatever number you're looking for, just make sure that the numbers up here, the combination of numbers, equal that number. So whatever those numbers are, put a 1 underneath. The numbers that are going to make your number go over, put a 0. Don't add those. Only add the ones that have a 1 to give you that result. Questions, class? And again, this is just how to do those conversions. I just wanted to give you a quick, scheme of that. if you would like just this little table or something, or any of my examples, I'm glad to make them available to you. But anyway, just wanted to show you that. That's how we process ourselves as humans, convert a number to a binary. Just get this conversion matrix and put a 1 underneath the numbers that you need. When they add up, it gives you the right results. Okay, so anyway, so we see here, again, the 24 just tells you you're going to put 24 ones in front, because every IP address up here has a 1 below it. Okay, has what they call, this is called a subnet mask. They say it can be expressed as subnet mask, like right here. You know, if I put all ones in my yellow matrix, that would equal 255, because if I had all those numbers, you know, the 1, 2, 4, 6, 8, 16, 32, 16, 128, if I add all those numbers, it's going to give me 255. See, it has all ones. But anyway, don't let it throw you off or scare you from networking or anything like that. You know, like I said, this is the A+ class, but that's how they do that class. You can see here, host must be determined whether destination address is on the same network or not. What they're telling you here, class, is all they're saying is that if the numbers are not in, let's say we're in the classroom, if the address that you're sending to is not a computer in the classroom, then it's going to go out through the router to the internet to look for the computer on another network. That's all they're telling you here, class. Forwarding, IP forwarding. And then you have 2 types of addresses, the public and the private addresses. The public address are the addresses that are used when you go out to the internet. To have a public address, you have to buy it. If you don't buy it, then you're going to get what they call a private address. A private address, you don't pay for that address. It's free for you to use. But a private address can only be used inside your LAN. So if you're in our classroom, we have a LAN, you can communicate with each other using a private address, every computer having a private address. But if you try to go out to the internet, it's not going to work, because the internet only will acknowledge public addresses. Okay, so there's 2 kinds of public address and a private address. So normally, you know, if you're going out to the internet, that means you have a public address. Okay, that's the difference, class. But if you were going to use private addresses inside your network, this is the range of numbers you would use. You would start off with 10.0.0/8. Remember that /8 is what 8 ones, and then .0.0.0. If you use this one, this is what you would use if you decide to use the private addresses. The public addresses you don't worry about. So anyway, just again, just know that much: public and private addresses. So working for a company, you know you're going to be using public addresses, because how can you get out to the internet if you don't have a private address? And remember I said you have to go and set up the addresses on every computer. Well, this is where you would go. You would go to the IP address configuration. That's an option in Windows. We're going to see that option later on in this course. And when you go to that option, it's going to come up with a screen like this. And you're going to give the address on the computer. You're going to put it like in this example. You can see they're putting the address 192.168.0.2. Remember how they said earlier /24? Or this is the /24. That's the same representation, because this is all ones, because 255 is all ones. You have to have all of the 128 to 64 all the way to the 1 set to 1 to equal 255. So that's the reason you have 255, 255, 255. That really means all ones. And then you get the gateway. This is the address of your router to go out to the internet. Later on, we're going to talk about DNS. We're not going to talk about that now. But this is where you go and put the addresses. Let's say you did this one computer. You got to configure the next computer. Then you would give it the number, for example, 192.168.0.3. Okay? And then everything else is the same. And then you go to the next computer, 192.168.0.4, and so on. And you keep going till you do all the computers. So that's where you configure your computers, by doing that. And now the computers have an address. Now they can communicate on the network. So static versus dynamic host configuration. This address here, class, you already know. Now I go here, I give the address, and we're good. We're good to go. Now the computers are getting an address. Now they can communicate with each other. So you know, that's great. Now I know that you know, I have a working network because again, like I said, I have all the addresses set up. So it's a good thing. Okay, so now let me just ask the question. For example, Houston Community College has 6,000 plus employees, okay? And they have 80,000 students. So let's say all in all, they have 10,000 computers in all the campuses. Well, stop and think about it. If you have to go in there and you have to set up the IP addresses on 10,000 computers, it's going to take you a long time to do every computer, right, class? So there's another way of doing big networks. Instead of you, the person, setting up the addresses manually, you can set up a certain option in networking called DHCP. We're going to see that next. And DHCP has the numbers that you need to set the addresses. It has the beginning number and it has the last number. For example, let's say the beginning number was 1 and the last number was 250. That means you have 250 computers. You don't have to go into 250 computers and put the address. DHCP will do it automatically. On the first computer, it'll give it 192.168.0.1. On the second computer that comes up, it'll give it 192.168.0.2, all the way to 255 automatically. You didn't have to do it yourself. And this is the way it's done in big companies, because you don't have the time to go do that many computers manually. So that feature of networking is called DHCP. Static is where you will type it in, just like I saw right here, like you saw right here. Dynamically is where it does it automatically. And you go in, again, we're looking at a wireless router that we saw earlier here. And remember I told you it has options that you have to configure. And you can configure the DHCP. And right here, if you can see it, it has it that you're going to run DHCP right here. And you give it the address, and you give it the beginning number, the pool, and DHCP. You said we're going to use DHCP because we want to give the numbers automatically. We don't want to do 200 numbers or 100 numbers. It's too much work for my techs. So you come here, you configure this, and see here they're going to give out numbers automatically. The first computer that's turned on is going to have the number 192.168.1.100. The second computer that's turned on will have the number 192.168.1.101. The next computer will have the number 192.168.1.101, and so on until it gets to the last computer of 199. So it did it automatically. The system does it for you automatically. So that's the way it's done in the real world, class. Unless you have like a little network of 5 or 6 computers, you can do it yourself manually. But for many users, this is what you have to do. Have the system assign it automatically. All you do is give the beginning number of the range and the last number, and then it'll give those numbers automatically. And that is great for us. It saves us a lot of work. And you did this by connecting to, in this case, it's your access router, your wireless access router, and you went to the advanced tab, and you went to the LAN settings, local area network settings, and you said, I want to give numbers automatic, DHCP, right here. That's where you did that. So the router also has to be configured. So again, they're just showing you a picture here. In this one, if we look at it, we can see here, this is the router that takes the computers out to the internet. And you can see here, they're still in their wireless router. They went to advanced, they went to the internet, and then here they're just putting the IP address of the router. Because the router also, think of the router as being another computer, it also has to have an address. So this is going to have 192.168.0.101. So you can see it. So all this is configured through your equipment that will do things for you automatically. Okay, so we saw class the IP addressing, right? 4 octets. Example 192.168.0.2, right? So the 4 octets. Well, they have come up with a newer version of addressing. This newer version of addressing, class, is called IP version 6 because they were running out of the IP version 4 numbers. They said, well, we're going to have to do something. So let's come up with a new version that has a lot more numbers so we don't run out of these addresses. Because if you stop and think of the internet, there's millions and millions of people out there that use the internet. So these numbers eventually begin to run out. But with IP version 6, that gave us more numbers that now we don't run out. And they call that IP version 6. And IP version 6 is the number is longer. And they give you a breakdown here, 64 bits here and 64 bits over here. This is the network ID. Everybody has the same number in the network, but each computer has a different number. Remember, for example, 192.168.0, everyone has that, but over here, it would be .1, and then .2, .3, and so on. But look at an IP version phone number is how many bits? 32 bits. An IP version 6 number is each side has 64 bits. So they made it much bigger, and it's written in now in another numbering system in hexadecimal. That's the base 16 numbering system, and that is version 6 for your class. Just a little introduction to let you know. Yeah, this is how the number has changed. Later on, they'll show us what an actual number of IP version 6 looks like. So again, what did we look at, class? We looked at IP version 4 addressing. We looked at the network prefixes, right? Every network has the same numbers, 192.168.0. So every computer on the network would have that number, but the fourth number would be different, because the numbers have to be unique. There's the IP4 forwarding means that it takes your message that you send from your local area network out through the router to the wide area network. Again, you're sending an email to your friend. It's going to forward it outside of your local area network because your friend lives in Florida. It's got to go all the way to Florida. So forwarding. And then you have two addresses, public and private. The ones that you use when you out on the internet, the number is a public number. If you were not going to go out to the internet, you use private numbers. But of course, nowadays, everybody needs to get out to the internet. So we know we're going to be using public numbers. Private numbers only allow you to connect inside of your local network. And then you saw how you go in there and you set the number, right? You say 192.168.0.2 on every computer, and then whatever the last number happens to be. And then the static versus the dynamic. The static is which one? The one you, the technician, has to type in. The dynamic is where you say, we have 250 employees. I don't want to go in there and type 250 computers. So I go to my router and configure DHCP, remember DHCP, and I put my starting number and my ending number, and then the system will automatically give the numbers out. So, and then we have, the router also has to have an IP address. And then there's a new addressing format. Now it's called IP version 6 addressing. Right now, companies use both IP version 4 and IP version 6. Okay, here compare protocols and ports. Okay, we're out of the woods of the binary conversions that you just saw. Here, let's look at this last topic. This is going to talk about another thing that goes with networks. This is called protocols and ports. It's going to be a little bit more clear to you this topic here. So here we have something called protocols and ports. When you send out your messages and your communications, it has certain identifiers, okay? And certain identifiers are pre-established. For example, looking at this class, if I'm working with right here, for example, let me find one here. If I'm going out to the internet, okay, computers use something called protocols and ports. So the computer is going to use the port number 80. You don't do anything. Just by the simple fact that you went out to the internet, the system automatically detects that. It says, oh, they're going out to the internet, so we're using port 80. Okay? If you are sending email, or the system automatically says, oh, they're sending, okay, the term is sending, not receiving, but sending. The number that it's gonna use is 25. So there's some pre-configured numbers. They're called ports that are attached to a certain application or certain function. So port 80 is a number that you'll remember. It has to do with going out to the internet. Port 25 is that number. You'll know that it's attached to the process of sending out email. There's other well-known ports. We won't get into those until we get to those in the chapter. For now, understand what I mean by this. So if somebody tells you, oh, you're going out to the internet, you say yes. Oh, what port number are you using? It automatically remembers port 80. It doesn't change. It's port 80. There's another one for security, but we're not looking at that right now. It's port 80. If you're sending out email, oh, that's port 25. They're not showing it here, but if you get an email coming in that's receiving email, that would be port 110. So anyway, just know what ports are. And it's not like you go and plug in those numbers anywhere. The system automatically does it, guys. They're just telling you that because you are a technician. It's good for you to have an insight how things are operating behind the scenes. So anyway, you have something here called connection-oriented transport protocol. What connection-oriented protocol means, class, is this. If you're sending out information to somebody else, and if the data is going through the wire, and let's say there's some interference and some of the information gets lost, the system will send the message back to the sending computer, and it will tell it, records 8, 9, and 10 got lost. Please resend them. And then they will resend them. So when the data gets, the information of the file gets to the receiver, all the information is there. Okay? It makes sure that any lost data gets recovered. So you can have the full file without any missing information. That's what connection-oriented means. Connection-oriented. Okay? The connection gets established, and any data that doesn't get received will get resent. And then we did talk about security with port 80. We said going out to the internet is port 80. Here we see some, because here they talk about ports, and then we have protocols. Each port is connected to the protocol. So the internet uses port 80, but it also has a protocol that goes with it. The protocol for internet is HTTP. And if you're using the secure connection, if you're buying something from the internet, going to use your credit card, then it uses the secure one. It uses HTTPS. S stands for secure. That port number is not port 80. That is port 443. Later on, you'll see a list, class. And there's another utility that goes with TCP called Secure Shell that's to connect remotely to other equipment. And it has its own protocol. I believe for Secure Shell is 22 or in 23. But anyway, just know that you have two things linked to the transmissions. It's protocols and ports. And again, it's behind the scenes. You don't plug in those numbers. But if you remember some of those, at least you're a little bit intelligent about what happens behind the scenes with computers. Here, for example, in DNS, for instance, DHCP is the one that gives the IP addresses automatically. Okay, that uses protocol UDP, and the ports that it uses is 67. The SNMP for security, it uses different protocols. Here you have, let me see one we can relate to, email. Remember I said outgoing email is port 25. The protocol is SNTP. For email that's coming in is POP3. The port number is 110. Okay, so for going out to the internet, HTTP, port 80. For if you're doing it secure, if you're buying from Amazon or you do online banking, it's HTTPS, stands for security. That's port number 443. So anyway, a nice little table for you to review right here. So we looked at the protocols and ports. So every utility that you run on your computer has two things attached to it, the protocol and the port. And TCP is the protocol that sends out information, and if data gets lost, it will recover it. And let me, okay, I just want to see here, connection oriented. Let me see, assign, allow the receiver, allows, okay, okay. So anyway, and then we looked at the well-known ports right here, well-known. Okay, here, let's just see. We got one more set here, and we'll finish the lesson. Just bear with me here. Okay, this is compared network configuration concepts. Okay, here is DHCP. So one more time, class. DHCP, I said, was for what? I said it was for what? For giving the numbers out automatically. So I'm going to tell you now, class, most places where you work, it's going to be done by DHCP. You're not the one that's going to go out there and start typing in the addresses on the computers. You saw how it worked with the router. You go into the router, you select DHCP, and we're on slide 33. Let me go back just to refresh. Right here. You say, okay, I started working with the company. They want me to give the addresses to the computers. Let me get my laptop. Let me connect the wire from my laptop to the router. This is the router here. When you connect, the router opens up, and you say, okay, I know that I have to set it up in the advanced tab in the LAN settings. And you go there, and then you select DHCP right here. DHCP, you check it. I'm going to do DHCP. So what are the numbers that you're going to give to the computers? Well, I'm going to start off with 192.168.1.100, and I'm going to go all the way to 192.168.1.199. So how many numbers are you going to have? You're going to have 100 numbers. So you have 100 endpoints. So the first computer that's turned on will have this number, 192.168.1.100. The second computer that's turned on when the person comes in to work in the morning, it'll give it the number 192.168.1.101. And then the next one, 102, 103, all the way till it gets to 199. Okay, so now you understand DHCP. It's going to give the number automatically. And when does it give it? When the employee turns on their computer, the computer doesn't have an address, and it's going to raise its hand. It's going to say, I need an address. I don't have one. And DHCP is going to see that, and it's going to give it the number. It's going to send it the number. Okay? And so that's how it gets the address automatically. So really, the way it works is you have the DHCP scope. We just saw that 192.168. What was it? That 0.100, all the way to 192.168. That 0.199. Okay, so now you have the numbers to give out. So that's what you have to do. Set up the scope, and you tell it these numbers that I'm letting you have them for a lease period. Normally it's 7 days, and then it'll renew before the number runs out. It'll renew again, so it'll have that number for a long time. That's the number it'll use. And then there's certain exceptions, like the reservations or numbers that are given to certain equipment, like the printers that are Netwrk. So their number will never change. It stays fixed. But again, that's the DHCP. You already saw. You go in there, you set the scope, the beginning number all the way to the ending number. Okay, now they talk about domain name system. Okay, domain name system class is DNS for short, DNS. Look at what it says here, class. Okay, the domain name system, it says resolve friendly names assigned to host to IP addresses. So everything on a network has to have an address. If you need to go out to a web page, okay, yeah, you need to go out to Microsoft.com. You type in www.microsoft.com. Well, what you're typing in is you're typing in the address of their server of Microsoft. Well, the server's a computer. It has an address, okay? So computers only like to talk to each other and find each other with numbers, with an address. That's a number, not a name. The name is only for us, the people, because it's easier for us to use a name and not a number, okay? So they call that the friendly name. So like right here, they have some friendly names here, like www.515webnet and so on. So the way it works is if you needed to go out to a web page, think of the DNS is what allows you to find the web pages. So you're going out to Microsoft.com, you type that in, and then the system says, I don't like a name. I like a number. Give me a number. So based on the name you typed in, and you typed in Microsoft.com, it's going to go into another computer you have on your network called a DNS server, and it's going to look for a list that has all the websites, okay, the web page names. And then once it finds Microsoft, to the right of Microsoft, adjacent to Microsoft, the name Microsoft, it has the IP address. And then it'll get the address to your computer. We're not seeing this with our eyes. It's happening internally. And then it goes out to Microsoft and finds the web page. So a good way to remember DNS name system is what allows you to find the web pages, okay? So you type in the name, it goes to this list that has the name connected to the IP address, and then it uses the address to find the web page. It works the same to find computers in your network. There's a list, it has a computer name, and then it goes to this list, and next to the computer name is an IP address, and it finds the computer. So DNS. But for now, to keep it straight in your mind, remember DNS allows me to find web pages. So because the person uses a friendly name, Microsoft.com, but computer uses the IP address of that friendly name. And again, once you type in the web page name, this is the process it goes through to find the web page. Once it finds it, it sends a web page back to your computer, and then you see that web page. So there's a little map for you to study the process. Again, it's behind the scenes. We don't get to see it, but here again, one more time, just so you can be aware how it works. And remember what I just said earlier. It goes to this list and it looks for the name and finds the address. Well, this list is stored inside this computer, which is a DNS server. Okay, and all the records in the DNS server are in this, are in there, in this list that I keep talking about. So right here, if you were to look inside DNS, you would see anything that has an A right here, is the, you know, is what I'm talking about. So if you were, well, they don't have, if you were going to find this location called, let's say you were looking for DC10. You go to DC10, www.dc10.com. It comes to this list that I said, and it searches. I said, oh, there's DC10, but I can't go find the web page because that name doesn't mean anything to me. I need the address. So to the right, adjacent to it, it picks up the address, and then it goes gets your web page using a number. So this list here is very, very long. It has a lot of addresses in there. Okay, so that's how it finds it. So you type in www.microsoft.com, it would look here in this list. If it would find it, let's say this was Microsoft.com, or let's say this was it right here. It said, okay, I found Microsoft. I can't get the web page with the name of Microsoft, but I can get the address right here, and then go get the web page. So again, that's DNS. It's a list of a name linked to an IP address. And where is this list stored? It's stored in a server called a DNS. There's some records there, and that list, all these web pages are identified with the letter A, right here, A, or AAA if you're using IP version 6 addresses. Okay? If I don't know if they show it here, but if there was an email server, that the name here would not right here, the type would not be A, it would be MX. MX represents an email server. Again, we're not DNS administrators. We're just telling you that this is what DNS is, how it works, so you can have a basic idea. And then there's ways to control class. Here, I won't get too much more, you know, like DNS spam management records that don't belong, you know, spam is unsolicited messages and stuff like that. There's a way to stop all that. Just a little bit of FYI information for you. But the main thing is I want to grasp the main concept of DNS. It takes a name, changes it to an IP address to go find your web page. So DNS helps you find your web page. Here they talk about virtual LANs, divide local network into separate broadcast domains. We're going to cover virtualization class, and I promise you this is going to be explained in detail, and by then you'll feel more comfortable with a little bit more of networking. So I'm not going to get too much into this. Virtual LANs is something known as virtualization. We haven't even covered virtualization, so I'm going to kind of hold off a little bit until we cover a little bit more about virtual LANs. But really, just VLANs is just a way to separate your network into smaller chunks. In other words, let me just give you an example. Let's say the West Loop campus at Houston Community College. You see the building is very big. Well, you say, you know what? It's a very big network. I want to break it up into more controlled size portions of it. You could separate the whole building into 4 parts. Think of 4 equal parts, and now you would have 4 squares. You have the big square. You break it up into four. So now you have 4 squares, and then you could configure each square to be a network. So now instead of having one big network, you're going to have 4 smaller networks, class. It's just breaking down your network into smaller, more easy to control portions of it. That's a virtual LANs, VLANs. So just know that that's what it's for. You know, the example of West Loop is simple, so you can understand. But there's some companies that are very large, very, very large, that they say one network is just huge. It's so hard to control. So we're going to break it up into smaller portions and hire a network technician for each portion of our network. You know, let's say they broke it up into 4, and each network had 1,000 So now you have 1,000 on each one. But if you didn't break it up, it was one single network with 4,000 computers. But when you broke it up into 4 networks in 1,000 computers. So now you know it's more manageable, class. It's a more manageable network. That's what VLANs allow you to do. Just a subnet, they call it subnet, segmenting, making your network, breaking it up into smaller pieces for easier administration. We'll talk more about that as we progress. So the virtual private networks, really, they're just those are the other one were VLANs, virtual, and this is virtual private network. All that is, class, here. Just look at the diagram. Just kind of break it down in here in the picture that explains it better. If you work from home, okay, you work from home, and this is your company over here. You can get to all the files in your company if you establish a connection, and that connection known as VPN. We're going to look at it more as well. So it creates a direct link to get into your network. A lot of people now work from home, and they have been set up by the technicians with this VPN configuration, and now they can connect from home and access the files, just like you are right now. You're connected to my computer, and more than likely it's done through VPN because I set up the WebEx. When you click on the WebEx link and you get connected, you're being connected to the VPN. So right now you're connected, and you're connected to me, as you can see here. So perfect example is our connections that we have going right now. So you're at home, but you're connecting. Really, if you think about it, think of me as a school. So you're connected to the school. So VPN, a virtual private network. They call it a virtual private network because it's a secure network. Hackers, bad people on the internet cannot break in and mess with what's going in and out of your computer to me. Virtual private networks. So anyway, class, we looked at what? We looked at dynamic host configuration protocol, meaning what? I'm giving the addresses automatically to the computers. The domain name system is doing what? I'm taking the name Microsoft.com, changing it to an IP address to find that web page, which has to do with the DNS queries. And where do I find this list of the names that have the IP addresses? Well, I found that in the DNS. Remember, we looked at it, and it had a record type of an A. Remember A? And it had the name on the left and the IP address on the right. And then the virtual LANs, if I need to break up my network into smaller portions because it's too big. And then the virtual private network is I need to have a secure connection from where I am to the location I'm going to connect. Like right now, from your home to me, to my WebEx. So you have a secure link, directly connected session going on. So that's networking for you, class. So having said that, this concludes the lesson. One more thing that I want to do is do a quick CertMaster Lab walkthrough, and then we'll be done for the day so you can work on your labs. So let me stop sharing this one and get into the CertMaster Lab. So give me a couple of minutes here. If you need to take a bio break, definitely get one.